Hello dear students, how are you? I hope you are enjoying your online studies and for our new students let me introduce you myself Ashish Sharma and I'll be taking care of your physics subject and together on this online platform we are not only going to cram the physics or study the regular lectures, we're going to understand it and I will do with you as much practical interaction as much possible. So before we start our today's lecture, which is about density and buoyancy, let me give you a brief recap about our previous lecture in which we discussed about thrust and pressure. We discussed how thrust is different from force as thrust is particularly perpendicular force to any surface and pressure is defined as force per unit area. We have also discussed applications of pressure, like if we increase the area the pressure will decrease, and if we will decrease the area for same force the pressure will increase. Okay, in last lecture we also discussed little about buoyancy. In this lecture I am going to discuss more about density and buoyancy. So let us first understand what is density. So you might have seen different objects around you, like some objects which occupy smaller space but they are very heavy. It is difficult to lift them, like stone, iron, and metals, copper, etc. On the other hand, there are things which occupy large volume but they are not that heavy. For example, cushions, pillow, cotton, the packet of chips, etc. So these things, they are occupying comparatively large volume but their weight is very less, their mass is very less. So here I am having an example for you. Consider these two bulbs. One is a rubber ball and the other is iron ball. So you can see that even the volume of this iron ball is much smaller comparing to this crazy ball. Though you might have played with this, everyone has played with this in their childhood once or twice, doesn't matter. So you can see here this iron ball is much smaller in size comparing to this ball, but still this is very heavy. The metallic ball is much heavier than the rubber ball. What is making it heavier than this? The size is small because it is a different element. It's iron, and the atomic mass of iron is greater than the atomic mass of the rubber, which is used here. The constituents of rubber, like sulfur and the other things which we use for making the rubber. So, in terms of density, we can say iron is more denser than rubber because it is having more mass in given volume comparing to this rubber ball. So the density of iron is greater than density of this ball. Let us understand them in terms of physics. Density is defined as mass per unit volume of an object. So this mass per unit volume is known as density, and we represent density by capital D or by Greek alphabet rho. They both have used extensively in our text of physics for representing density. So what is the formula of density? Density is defined as mass per unit volume. What is the unit of density? So as you are dividing mass by volume, the unit of density is also the unit of mass divided by unit of volume. So unit of mass, we know that is kilogram, and unit of volume is meter cube. These are the SI units of mass and volume, kilogram and meter cube. So unit of density is going to be kilogram per meter cube. Also, we know that mass can also be expressed in gram and volume can also be expressed in centimeter cube. So gram per centimeter cube is also the unit of density. We can express the density of any substance in any of the unit which we like. We can express it in gram per centimeter cube, or we can express it in kilogram per meter cube. Let us take a simple example for understanding this. And let me tell you, while writing, we can also write these units like this: kilogram per meter cube, or kilogram meter minus 3, because any quantity which when it comes from denominator to numerator, so we can write it by changing the sign of its power. Okay, similarly we can write it like gram slash centimeter cube, or gram centimeter minus 3. So this is indicating the same thing. Some students get confused that is it gram per centimeter cube, or is it something else, minus 3, some printing mistake or anything like that. So let me tell you, these are the same things. You can write like gram per centimeter cube or gram centimeter cube minus 3. Similarly in kilogram per meter cube or kilogram meter cube minus 3. So first let me discuss with you a numerical in which we will calculate the density, and we will also convert from one unit to another. So given mass of a cube whose side is 10 centimeter is 5 kilogram. Calculate density in kilogram per meter cube and gram per centimeter cube both. So my dear students, as you can see in this numerical, a very normal case is given. The side of the cube is given in centimeter, but the mass of the cube is given in kg. So if you will divide the mass in kg by the volume in centimeter cube, you will get your unit in kilogram per centimeter cube. But I told you that there are two famous units for the density. Either they can be kilogram per meter cube or gram per centimeter cube, and in these units we have to calculate. So for first, let us calculate the density in gram per centimeter cube, and for calculating it in gram per centimeter cube, our length is already in centimeters, so our volume will automatically come in centimeter. That is not a problem. Our mass is in kg, so we must convert it into grams. We know that 1 kilogram is equal to 1000 gram. Hence your 5 kilogram is equal to 5000 gram. So here is your m, which is 5000 gram, and we know that for cube the formula for volume V is side raised to power 3, side into side into side, or side cube. The side of the cube is given 10 centimeter, so 10 centimeter raised to power 3 will give you 1000 centimeter cube, and that is your V. Now we have m with us, we have V with us, and we can calculate the density D by dividing mass by given volume. So dividing your 5000 gram mass by your 1000 centimeter cube volume, all 3 zeros will get cancelled with the 3 zeros above, and we will get 5 gram per centimeter cube. So that is your density D, 5 gram per centimeter cube. This is your density in gram per centimeter cube. Now what we will do for calculating this in kilogram per meter cube? Well, that is very simple. If you want to convert your density given from gram per centimeter cube to kilogram per meter cube, you simply multiply it by 1000. So if I will multiply my density 5 gram per centimeter cube by 1000, then I will get 5000 kilogram per meter cube. So this is a simple conversion which you must remember. For converting from density given in gram per centimeter cube to kilogram per meter cube, you multiply it by 1000, and vice versa. If you are given density in kilogram per meter cube, and you want to convert it in gram per centimeter cube, you simply divide it by 1000. Okay, so after discussing about density, now it is very important to discuss about relative density or specific gravity, as these concepts are very useful for understanding the concept of buoyancy and Archimedes principle in my coming lectures. So what is relative density or what is specific gravity? Relative density or specific gravity is defined as ratio of, okay, it is defined as ratio of density of given substance to density of water. So mathematically, relative density, which we generally represent by RD, relative density is defined as density of given substance divided by density of water. This is the formula for relative density. So what is interesting fact about relative density? It has no units, because it is a ratio. So if you are taking density of given substance in gram per centimeter cube, then you also have to put the density of water in gram per centimeter cube. The units of both the ratio must be same for finding the correct value of relative density. If you are taking the density of object in per meter cube, then you have to take density of water also in kilogram per meter cube for getting the correct value of relative density. For example, if density of ice is 0.9 gram per centimeter cube and density of water is 1 gram per centimeter cube, calculate relative density of ice. This is very simple numerical. As you can see that both the densities are given in same units, so half of our work is already done, and we'll simply take the ratio of density of water to density of density of ice to density of water, and I will get 0.9 gram per centimeter cube divided by 1 gram per centimeter cube. The units will get cancelled and I will get 0.9. So relative density of ice is 0.9. It has no units. Okay, I hope you enjoyed the lecture, and soon I will be sharing the next lecture, second part of this, in which I am going to discuss with you buoyancy and apparent weight in detail. Okay, have a nice day. Thank you. Thanks for watching.